In this lecture, we'll implement the fields and properties of our die class. As a reminder, here in the UML diagram, I've put an orange square around the fields and properties we're going to implement, so let's go do that now. To start us off, I've created a new project called the die example, and this is the code we'll use to test our die class. We won't actually be able to do that until the next lecture, but I wanted to include it here now. And the first thing we need to do is add a new class for our die class. Because we've never done that before, I'm going to show you how to do it. On the right in the Solution Explorer, I can right-click my project name, die example here, the bold-faced die example, and I can say Add New Item. Luckily, the very top kind of item I can add is class, so I'll do that. But I'm going to change the name from class 1 to die instead. And when I click the add button, I get a new class named die. I'll add a documentation comment that just says this is a die. And for this lecture, we're going to add our fields and properties. The first thing I'm going to do is I'm going to create a region called fields, and I'll put end region as well for that region. And now I'll put my fields inside this region. We know we have two fields. We have num sides and top side, and we know they're both integers. And we declare fields just like we declare variables because fields are variables. They're just variables that are available throughout our class. Int num sides and int top side. As a reminder about regions, regions are not required for C#. Regions are a way for us to organize our code. They don't get turned into executable code when we build our solution or anything. They're just to help us organize our code, and we can collapse and expand our regions if our code gets really large and so on. So I regularly use regions in my code, but regions are really just a way for us to make it easier for us to work in our integrated development environment. Remember that we've talked about the fact that using information hiding is a really good thing in our object-oriented work. And we've said that our fields should not be accessible to consumers of the class, to code that's outside the class. We could actually make a field visible to consumers of the class by making that field public. And this keyword public is called an access modifier because it modifies access to this particular field. And this would be a horrible thing. We don't want to break information hiding by doing this, so we don't really want our fields to be public. We want our fields to be private. And because fields should be private, that's a best practice in object-oriented development. If we don't put an access modifier, the field is by default private. So we can just declare it as a variable. It will be private. It's good information hiding. So now we've declared our two fields for our die class. The next thing we'll do is declare our properties. I'll put those in a region as well. And we know we have two properties. Let's work on the first one first. Our first property is going to be for num sides. And we do want to make our properties public because the whole point of doing our properties is to give consumers of the class access to the state of this die object. So in general, we'll make our properties public because they're for consumers of the class. We know that num sides is an int. And I'm going to name my property num sides with a capital N, just as we name our classes starting with a capital letter. And as we'll see later, we name our methods with a capital letter. That's standard C# capitalization. We actually have multiple ways that we can access properties. We can read those properties, we can write those properties, or we can both read and write. I'm going to show you doing both reading and writing for our numSides property, but then we'll talk about why one of those is perfectly reasonable and one of those is totally unreasonable. Let's do read first. To provide read access to a property, we provide something called a get accessor. And this get accessor has red squigglies right now because I haven't finished implementing it, which I'll do momentarily. But the other accessor we can provide, as IntelliSense is showing us, is we can also provide a set accessor. So get accessors provide us with reading capability. We can get the value of the property, and set accessors provide us with write access. We can write the value of the property. For getting numSides, we know that this property is giving a consumer of the class access to our state, access to the value of our numSides field. So this right here will get the value of our numSides variable. We know that's how variables work, right? We provide the name of the variable and the runtime system figures out the value of that variable. We're not quite done yet here because you can see we have red squigglies all over the place now. Just because we've retrieved the value of our numSides variable, we actually haven't provided it to the consumer of the class that's trying to access this property. Programmers come up with weird names for lots of stuff sometimes, at least it seems like that until you're an experienced programmer. But this is one of those cases where we don't have a weird keywords to use. We're trying to return this value to the consumer of the class. So we say return numSides. And as you can see, my red squigglies have gone away and a consumer of the class can now just read the numSides property. And we've done that a lot in our coding that we've done as consumers of classes, but this is the other side. This is the implementation of the class. For a set accessor for numSides, we want to set the value of our numSides variable. And to do that, we assign it to a special keyword called value. And I know I've talked to you about this a little bit, so it's okay to have a review of how that works. When the consumer of the class accesses the set accessor for the numSides property, it's pretty common to use an assignment statement to say that the property is set equal to some value. Let's say 5. Here inside the set accessor for the property, value gets the value 5, and then we set numSides equal to that value. So if you want to think of value inside a property as a special parameter that gets passed in when the set accessor is accessed by a consumer of the class, that's a reasonable way to think about it. Of course, set accessors can be much more powerful than this. One of the great benefits of using properties instead of making our fields public is we can control the validity of the data. Let's say we had a health field and a health property that had a set accessor. We know we want to keep our health between 0 and 100. So instead of saying something like health equal value here, we could say if health greater than or equal to 0 and health less than or equal to 100, then we set health equal to value. So if the provided value that gets passed in here is not in a valid range for health, we just don't change health. We don't let the consumer of the class destroy the validity of the data in our class. So there are some really powerful reasons to actually use set accessors with more complicated logic as appropriate to protect the validity of our data inside our class. Okay, one of these accessors is perfectly reasonable. The get accessor is perfectly reasonable. It makes sense to let a consumer of the class find out how many sides the die has. The set accessor for this property is totally unreasonable because what it would let the consumer of the class do after we created a die object is say, oh, I don't want the die to have that number of sides. If you think of this for a real die, it would be like picking up a die that you're using in a game and taking a file and shaving it off so you have another face on the die and then adding a number with magic marker on that face. That's called, wait, I know there's a word for it, cheating. So we are not going to provide a set accessor for our die. Once the die factory has created our new die object, you're not allowed to change how many sides the die has. So I'm going to delete that set accessor, and now I'll add the documentation comment that says gets the number of sides. The same arguments for get and set accessors apply for our other property, but this time we'll be getting the top side. So we'll call this property topside, and we'll return topside. And again, providing a set accessor for our topside is unreasonable. That would be like having somebody roll a die in a game, and if they didn't like the number that was on top, they could just reach over and spin the die and put a different number on top. That's also called cheating. And if you don't believe me, you should take a trip to Las Vegas and go to the craps table, and if you don't like your roll, just reach over and change what's on top of the die. You'll have an interesting life experience as you discover how the casino responds to that cheating that you're trying to do by changing the top side. So just as for num sides, we'll only provide a get accessor for our top side property. And I'll save all my changes and we'll build to show that everything builds fine. At this point, our next step should be that we actually test these properties, that we create a die object and we make sure these properties are returning the correct values for the die object we created. Unfortunately, we haven't written our die constructors yet, so we'll have to defer testing these properties until the next lecture. To recap, in this lecture you learned how to implement fields and properties in a class. You learned how we can control the visibility of our fields and properties by using access modifiers like public and private. And you also learned about how to implement and when to implement the get and set accessors for properties.